Today we're going to talk about ionic bond. Before I start talking about what ionic bond is and how it's formed, I want to remind you of the structure of atom once again because it's very important to understand today's lesson. So this is the nucleus of an atom once again, which consists of proton and neutron. Proton carry the positive charge and neutron carry no charge. On the outside of the nucleus we have electron that is flying around the nucleus and it carries a negative charge. If an atom contains more proton than electron, then it will carry the charge of proton and it will be positive. If it contains more electron than proton, it will carry the charge of electron and it will be negative. If the number of proton and electrons are equals, and when the number of electron and proton equal in an atom, the positive and negative charge will cancel each other and the atom will be neutral. In other words, it will have no charge. A lot of times in atom, the number of proton is equal to the number of electrons. So the charge balance out and you don't have any total charge. But sometimes an atom can gain or lose electrons. So it gets more or fewer electrons than protons and then the number don't balance out anymore. It's left with more negative charge because it has more electrons or with more positive charge because it has more proton. Let me give you a couple examples of how this happens. Let's look at the atom sodium here. We're going to use this zoomed in version of the atom of sodium. As you see, we got the protons here in the nucleus in red and then the flying around on the outside I have these electrons which are drawn as black dots. Now we have left out the neutrons which also live in the nucleus with proton, but it's not big deal because neutrons don't have a charge at all. They are neutral, so they are not important for what we are talking about here anyways. Now sodium has, if we count them, 11 protons here in the nucleus and it has 11 electrons flying around. So the number of protons equals to the number of electrons, which means that my total net charge is 0. They cancel each other out, and so something that has no net charge like this sodium atom, we call it neutral. See this electron right here, it can lose it. And it flies off and usually goes into another atom. So let's look at what happens when this electron here gets lost. We're going to end up with a sodium atom that has 11 protons just like it did before, but because it lost an electron here, it will have only 10 electrons. So now the positive and negative charges don't balance out anymore and I am left with more positive charge than negative charge. So the thing now is going to have a charge of +1. So I can write this as Na+. This means that it has a positive charge where this guy over here, I'll probably just write Na. So Na+, here is an example of an ion because it has a charge. Let me show you another example. So this is an atom of oxygen. The atom that's drawn here has 8 protons here in the nucleus and it has 8 electrons outside. So we have the same number of protons and electrons, which means that the total charge is balanced out. Plus and minus balance out. So we have a net charge of 0. And I can say that my oxygen atom is neutral. It has no net charge, but oxygen can gain or lose electron. And actually, it really likes to gain 2 electrons. And here is the picture of the oxygen after it's gained 2 electrons. And now it still has 8 protons in the nucleus. And if I count up these electrons, it now has 10 electrons. So now the protons and electrons don't balance out anymore and I have more negative charge than positive. We got 2 more electrons than protons. So that means that my total net charge is going to be -2. I can write the symbol for this ion as O2- to show that it has 2- charge. For this guy over here, I can write only O. This is an ion because it has a charge. Now to learn about ionic bonds, we are going to focus on a chemical called sodium chloride. Sodium chloride is a fancy scientific name for table salt. The stuff that you put on your food. So sodium chloride is made of two types of atoms. We got sodium here, it's a symbol from the periodic table, and here is a sodium atom right here, and sodium chloride is also made of chlorine or chloride. I'll tell you what the difference between those is in a minute, but you don't have to worry about it right now. And here is a chlorine atom. Now, sodium chloride happen when these two atoms come together, then they are glued together by ionic bond. But the atoms that I have right here, they're not glued together. They are just kicking it over here. They have nothing to do with each other. So I want to talk about what happens to get these separate atoms connected and glued together like this. Why these two atoms are connected is because they ended up getting electronical charges. Okay, this atom is going to end up getting a negative charge, and this atom is going to end up getting a positive charge. What two oppositely charged things like to do? They like to attract. So because they think get different electrical charge, they're going to be held together by those different charges. So let's look at the step that we have to take to go from this to this. The first step is pretty much what I got right here. We are starting with two separate atoms that aren't connected. We got a metal out of the sodium here and the non-metal chlorine over here. Now, the first thing that happens on the road to an ionic bond is that the sodium atom gives one of its electrons to the chlorine atom. Here is the electron moving between the two of them from the sodium to the chlorine. Now, this electron moving will change the charges of these two atoms. Okay, what happens in the next step? Sodium gives away one of its electrons to the chlorine. So it loses one electron. It has one fewer electron, and that's going to give it a positive charge because it's lost an electron. But chlorine gained one of the electrons from sodium. So it's going to become negative. It's going to get a negative charge because of that extra electron. So now these two atoms take on electrical charges. And what do we call atoms that have charge? We call them ions. Sodium becomes positive, chlorine becomes negative. Now here's where the difference between chlorine and chloride comes. Chlorine is what we call the chlorine atom, where it's neutral. So up here, this is a non-metal atom, chlorine. Just hanging out here is a chlorine zero charge. But down here, after it's received one of the electrons from sodium, it gets a negative charge. It becomes negative ion. And now we change its name a little bit. We call it chloride. Chlorine and chloride, they are the same atom. It's just chlorine is the version of the chlorine with a neutral charge, zero charge. And chloride is the version of the chlorine that has one minus charge. And it got that one minus charge because sodium gave one of its electrons to the chlorine, turning it into a negative chloride. A transfer of electrons gives this one a positive charge and this one a negative charge. And what the opposite charges like to do, they like to stick together. And so this is what we end up with. The two atoms glued together because there are opposite charges are holding them together. Okay, so there are really three important steps in ionic bond forming. For example, of sodium chloride, here's what they are. The first step is an electron transfers from sodium to chlorine. Sodium gives one of its electrons to chlorine. Sodium loses an electron, so it gives it a positive charge. This becomes positive, and chlorine, because it has gotten an extra electron, get a negative charge. And they both turn into ion with a charge, and since chlorine becomes negative, we call it chloride. And then the last step after the ions is that the oppositely charged atoms stick together because of the opposite charge. So basically the opposite charges act like a glue and hold the atoms together. Okay, so this is just the very basics of how ionic bond form. We haven't really talked about the details, why the electrons move. And now I want you to look at why and how these steps happen during the formation of ionic bonds. In order to really understand what's going on in ionic bonding, we have to take a look at the individual electrons that live in sodium and live in chlorine. As you probably know, there are specific places in an atom where electrons can live. I have a diagram of this here. Each one of these little circles represent a spot that an electron can live in an atom. And you will see that these little electron spots are arranged in rings around the nucleus. Each one of these rings is called a shell or an energy level. Okay, so we can use this diagram to figure out where the electrons live in sodium and where they live in chlorine. First thing we've got to do is we've got to find out how many electrons there are in these atoms. Now sodium here, you look it up on the periodic table, it's got this 11 here. That means it has an atomic number of 11. There are 11 protons in sodium. Now remember, when ionic bonding starts, these atoms are not yet ions. They don't have a charge. They are neutral. That means that they have the same number of protons and electrons. That means there are also 11 electrons in sodium atom. Okay, the same thing is true for chlorine. It has an atomic number of 17 protons. It's starting out without a charge, so it has 17 protons and 17 electrons. Now we can take one of these diagrams and fill it in from the center on out with a number of electrons. So for sodium, that's going to look like this. 11 electrons arranged around the atom from the center out. And for chlorine, it's going to look like this. 17 electrons arranged around this from the center out. Now you may not be able to tell from this diagram, but these are two very unhappy atoms. The reason why has to do with the valence shells. Valence shell is the outermost level of energy that contains electrons. For example, this is the valence shell of sodium. It's got one electron here. And this is the valence shell for chlorine. Okay. The reason why these two atoms are so pissed off is because every atom wants to have a full valence shell. It's like every atom's goal in life. Sodium really unhappy because it only has one electron and it had these 7 empty spots. Chlorine, on the other hand, is also upset because it's got emotionally full valence shell, but it's got one empty spot. It's so close. It's so close, but it's still super unhappy because the valence shell isn't full. So sodium and chlorine are both unhappy. They both want to fix their situation, trying to fix it. That's how they are going to end up with an ionic bond. So how are sodium and chlorine going to get happier? How are they going to fix their situation? How are they going to try to fill their valence shells? Well, take a look at this. They can help each other out. Chlorine has one spot left before it's able to fill its valence shell. And so what happens is sodium can give chlorine one of its electrons. So these electrons move from sodium to chlorine to fill this spot. Here is what we end up with. Let me just show you. We got sodium, we got chlorine, and this electron up here moves between them. It leaves sodium and it goes into chlorine. And now chlorine has filled this empty spot with one of sodium electrons. So now chlorine is super happy. It has a full valence shell. But take a look at sodium over here. Though you may not know it, sodium has also achieved its goal in life. Because when it gave this one electron to chlorine, it totally emptied out this valence shell. Now you might think, okay, that made it even worse because now it has 8 empty spots. It has to fill. here's the thing. If you can get rid of all of the electrons in your valence shell, it's like that valence shell just disappeared. Sodium doesn't even have to worry about it anymore. So it gave away its last electron in its valence shell, and now it's like the valence shell just disappeared. And this is not sodium new valence shell. And check it out, it's totally full. So by giving away that one electron, it could get rid of its whole outer shell, and this is its new valence shell. It's full and sodium's happy. So this is what we end up with. And that's it. Now I want to say how this is going on one more time, really quick, step by step. So we start out with sodium and chlorine. They are both neutral. They have the same number of protons and electrons, but they are both unhappy because their valence shell are not full. Chlorine has an empty spot. Sodium has only one electron, valence shell. So the electron here moves from sodium to chlorine. So now chlorine got one more electron and it has a full valence shell. Sodium empties out its valence shell, so it's almost like that old valence shell just disappeared. We end up with this, and a new valence shell is totally full. So now sodium and chlorine are both able to get full valence shells, but electrons had to move in this process. So now sodium has one fewer electron than proton, so it gets 1 plus charge. Chlorine got one more electron, so it has one more electron than proton, so it has a 1 minus charge. So these guys, they trade electrons, or an electron moves from sodium to chlorine in order for them to get full valence shells. And it's in the process of that happening that they end up getting charges. So guys, this is one of the most complex topics in chemistry. People have so much trouble with it. So I urge you, maybe check out this video again. Watch it from the beginning. Make sure you really understand it before you move on. Now I want to talk a little bit about the shape and structure that ionic compound make. So we've got sodium here and we got chlorine here. And we're talking about how they get opposite charges and they end up sticking together, forming a shape kind of like this. Okay, but so far we've only talked about two atoms, one of each in nature. Rarely would we find just two atoms, okay? Usually there are going to be a lot more than two atoms that want to exchange electrons and combine together. So what happens when we have a bunch of atoms that could all do ionic bonding? Well, that you might want to think of is each pair of these atoms would form a structure kind of like this, okay? But here is the thing. These guys wouldn't stay separate, okay? This is super important. They wouldn't stay separate because opposite charges attract, not only in groups of two, okay? So this positive and this negative, they are attracted to each other. But this positive charged sodium will also be attracted to this negatively charged chloride over here. Okay, so these two things are going to end up connecting to each other because of that attraction, right? And then there is this guy over here, and this positive charged sodium could be attracted to this negatively charged chloride, and this negative charge could be attracted to this positive charge. So this will be come together just like here, okay? So we start building a much bigger shape if we get a bunch of these sodium and chlorine atoms getting charged and coming together. We are going to end up with a shape like this. This is called a lattice structure, okay? And you can see how these ions pack it really closely together and how they are making this larger shape. Okay, here have a negative ion and is surrounded by 4 positive ions because they are all attracted together. And over here we've got this positive ion that is surrounded by a whole bunch of negatively charged ion. So the important thing to keep in mind is that ionic bonding, when you're talking about more than just two atoms, it don't only make this small group of two, but these groups are going to be attracted to each other and they are going to make much bigger structures that are going to become these lattice structures. Whenever you see a shape like this, keep in mind that is just one part of a bigger lattice structure that you get when a whole bunch of these different units come together, okay? So that's it, guys. I know this lesson was kind of complex, but please don't lose hope. Keep trying and you're gonna get it, I promise. And feel free to ask any question regarding the lesson, I will answer. And good luck. Goodbye.